day 2, and this should take you back to stuff that you did in advanced functions. That's why this course has a prerequisite of you having done the advanced functions course. By the end of this class, you're going to be able to calculate the slope of the function at any specific point. When you were doing that back in advanced functions, certainly if you're with me anyway, we call it the IROC, which is the instantaneous rate of change. And here's what it looked like. If you had a secant would be a line like this red line that goes through the graph at 2 spots. You could find the slope of the secant by just simply using your regular slope calculation, right? You know how those slope calculations look. You know, y1 minus y2 over x1 minus x2. That's how that looked. But then we could also get a little bit more specific and say we don't want the slope between 2 points on the graph. We want the slope at a point on the graph. So whereas the secant line was what we call an AROC, an average rate of change, when we wanted to find the slope at a particular point, we call it the IROC, and it was just a line that just kind of touches the edge of the function at one spot. That's what we were doing back then. So here's how we did it, right? Here's the IROC calculation. We took a point that we were trying to find at. So let's say this was a point 2, 1 or whatever it was. We took that point and we added on some little number to it. Like for instance, let's say that the equation was x squared plus 4x plus 2. Right? What we did is we said let h be 0.01. So we took the we took the let's say that 3 there, and we added on that 0.01 to it. So we'd get 3.01 here. Then we minus the 3 from it. That's minusing the a. And then on top of that, we put the value of the function at 3.01, and then we minus the value of the function itself. Right? So that's what that looked like. And hopefully you can remember that from last semester. So here's the calculation. 3.01 squared. So we take it and we put it into the function, right? Plus 4 times 3.01 plus 2. So that's going to give us the value of the function at 3.01. We minus from that the actual value at 3, which is 23. And then we divide that by the x value. So 3.01 minus 3. But notice, of course, that the bottom here is always just, if you go back and look at this point up here, right? Where I'm pointing to, actually, let me use my stylus. I think it should be charged fairly well now. So let me grab it out of its holster here, right? If you can see where I'm pointing to here, the bottom of this is always going to be the f of a plus h minus the f of a simply over a. Because if you take a plus h and then you minus the a from it, it's just going to be leaving you with a. Right? So that's really what's always happening with this. So at the end of the day, this calculation works out to be 10.01. You don't have to go through all of the steps with this. I just want to make sure you remember this from last semester, last quadmester, when you did your advanced functions. All right, so hopefully this looks familiar to you, because we're about to apply this in a more general sense by doing this. We're going to use this formula, that the slope of the function at any point is going to be the f of a plus h, similar to what we had before, f of a plus h, minus the f of a, so whatever the value is at a, I'm just going to divide that by the h, just the h itself, because that's really what's left. If you take the function, the x value, and you subtract the original x value from it, you're just going to be left with whatever it is that you added on. Okay, let's see how that applies in this case. We want to use the formula that we created, this formula here, to evaluate the slope of the function when x is equal to 3. Well, the first thing we need to know is, what is the f of 3? Because that's part of the function, part of what we need, f of 3. What's the f of the function? At the point at which you're trying to get this slope, we want to know what that f is. So f of 3, of course, is equal to 2 times 3 squared minus 4 times 3. Okay? All right. What is the limit? We never seen that before. Well, we'll get there. We'll get there. All right. Is it 6? Well, let's find out. So that would be equal to, that's 9 times 2, which is 18, minus 12, which, yes, is equal to 6. All right? So here's a point that we're going to be talking about. We're talking about the point, the x and y are 3, 6. So it's at that point that we want to know what is the slope of the function, right? We'll talk about that limit stuff later on, Stephen. We'll get to that. But we want to know at that point on this quadratic function, the 3, 6, that's a point on the function. You put 3 and you get 6. That's a point on the function. What is the slope at that particular point? And we're not going to use IROC anymore. We're going to use an approach which is similar to IROC, but we're going to just simply, well, let's see what happens. So I'm going to go ahead and say this. The f, and this little apostrophe here means the slope of the function at a. That's what this f prime a actually means. So that's equal to get this slope, the limit as h approaches 0, we'll get to what that means later on, of, here is the function, here's the actual calculation. Now the f of a plus h. So I'm going to put the a plus h, which in this case is 3 plus h, right? That's my a plus h, right? I'm taking the, remember my a is 3. Let me just make sure that's clear. The a in this case is equal to 3. That's what the a is. So it's 3 plus h squared minus 4 times 3 plus h again. Okay? All right, so all I'm doing is putting in 3 plus h into this function. That's going to give me my f of a plus h. That's what this part here is. Just give me 1 second. All right, I'm putting the 3 plus h into the original function. Anytime I saw an x, I put the 3 plus h for it. So that's the first part of that. Then I'm going to subtract the f of a. So I'm going to subtract what the value of the function, should be black. I'm going to subtract what the value of the function is at a, which we agreed was 6. Remember, we talked about it being 6. Are you recording this lesson too? Yes, Alicia, I certainly am recording this lesson. Okay, so not to worry, you'll be able to go back through this again in more detail later on. Over the h. All right, so let me say this again. The 3 plus h, this a plus h here, f of a plus h, means put in a plus h anywhere I see x in the original function. So it's 2 times 3 plus h squared minus 4 times 3 plus h minus whatever the function value is at a. Well, we already decided the function value. When you put 3 into it, you get 6. All right? Can't find the note on the math video library. I thought it was there. I can double check that right now since you're asking. Just give me 1 second and I can see. Make sure you're looking at calculus. You're not looking at advanced functions anymore. You're done with that now. Right? Unit div 1.2. So the tangent functions. Oh, there's a video there for that. Ah, I see. Doesn't look like I have the notes for it. Yeah, but just follow with the video. Okay, let's just follow with the video for now. Okay. All right. So let's keep going. Let's keep going. So let's do a little bit more math now. So the limit as h approaches 0 of this massive looking function here. Let's take the 2 and multiply it by whatever this works out to be. Now, hopefully people are comfortable with what I'm about to do. When I square 3 plus h, it's not just going to be 9 plus h squared. That's not correct. It's 9 plus 6h plus h squared. And if you're not sure where I got that from, we can talk a little later on in that extra help period. You need to be able to square a bracket. So it's like taking 3 plus h and multiplying it by 3 plus h. I'm telling you it works out to be this. 9 plus 6h plus h squared. Minus, and again, I'm just continuing with the algebra here, minus 12 minus 4h minus 6. Okay, so far so good, and that's all over h, by the way. All right, okay, let's keep going. This I'm going to put aside for you to try out later on. Put that, where do I put that? I'll just put, actually, you know what, I'll just put that further down the page. That's for you, that's your practice example coming up. So that's equal to, stop me if there's any part of that you will need a bit to slow down on. The limit as h approaches 0 for, okay, I'm going to expand this bracket here now. So that's 18 plus 12h plus 2h squared minus 12 minus 4h minus 6 all over h. Okay, we're just going to collect our like terms now. Now, the good thing, if you notice, is that this minus 12 and that minus 6 and that 18 will all cancel each other out. And what I'm left with is, when I collect my terms, guess again, limit as h approaches 0. What I'm left with is the 2h squared. And so that takes this out. Then I'm left with a 12h and a minus 4h, which of course would be plus, I'm not sure why I'm using that color, plus 8h. That's all over h. All right, let me slow down and just make sure I haven't left anybody behind. We've accounted for all the terms on top now. The 18, the minus 12, and the minus 6, they knock each other out. The 2h squared is still there. The 12h and the minus 4h give us the plus 8h. And that's all over h. Now, can we factor this? Of course we can. Let's factor the top of this. So again, the limit as h approaches 0, I'm going to factor the top to give me 2h into h plus 4 all over h. So far, so good. Let me check in with the room. I like to check in from time to time to make sure everybody is with me on that. Ashwan, how about you? Are you okay with that so far? How about Adam? Adam, are you good with that so far? Are we good? Where's Adam? Okay, good. All right. So we know that we can cancel stuff out. This and this. So that's a 1 and a 1 here. So here's what we're left with. Here's what we're left with. Oh, sorry, hold on. Get that out of the way. Here's what we're left with. We're left with the limit as h approaches 0 of 2 into h plus 4, and that's all that's left. Why do we write limit at the side? We're going to talk about that now, Alicia, right? Because that's the essence of what the next step is. But so far, hopefully all the other algebra makes sense, right? All this other stuff that we did, right? When we plugged in the 3 plus h into the original function, all of that takes us to this. So now we're going to ask, what happens as h approaches 0? That's what this means. H with the arrow going to the 0. So as h gets smaller and smaller and smaller and start to disappear, really what we're left with is this thing here is 2 times 4, which of course is 8. That is in essence what the slope of the function is as h gets tinier and tinier and tinier, because that h approaching 0 means we're just going to consider it to be 0. That's what, so it would be okay to put 2h plus, up to absolutely 2h plus 8, but then we still are going to plug in that 0 into the function, Alexander, and still just end up with 8. Does that make sense, Alexander? Right, you're still going to end up with just simply 8 once that h gets put to 0. So I'm going to leave this here for you. We're going to come back to this example that I have on this page, right? Because we're going to get you to do that after we've done a few more of these, right? So we're going to move on to the next example. So next question. Use the form that you created. So the same formula in the box, f of a plus h minus f of a over h, to evaluate the slope of the tangent at x equals 3 for the following function, then find the equation of the tangent. And I'm giving you a little diagram here to show you that the point at which we want to find the slope is this point that I'm pointing to right now, the 3, 13, right? How do I know the function is 13 at 3? Because I can plug it in. I can find the f of 3, right? That's easy enough. The f of 3 for this function is 4 times 3 plus 3 over 3, which clearly is 12 plus 1, which is 13. So yes, the point that's on this line that we want to find the slope of the function is at 313. I mean, the answer is 13. Yeah, x equals, oh yeah, right, yes. No, x is not 13, but I know what you mean, Anika, that when you plug in 3, you get 13. The y value is actually 13. Yeah, I know you realize that. Okay. So let's go through the process again, right? Remember, we're going to find anywhere we see x, we're going to put a plus h. So here we go. So it's again going to be the limit as h approaches 0 for the following function. The bottom of the function is still going to be h, just like the last time. But on top, we're going to have a bunch of fractions. So we're going to have 4 times 3 plus h, just like the last time, plus 3 over 3 plus h. Again, anywhere I have an x, anywhere I see an x, I'm going to put the 3 plus h. Right? Remember, it's trying to get the thing at when x is 3. So putting in 3 plus some very small number, and we're calling that number h. We're calling that variable h. And then we're going to minus from that the 13, because that's the y value. That's what happens when you plug a into the function. This a here is 3. So putting 3 into this function gives us 30. So we're going to minus that 13. That's what this formula, that's what this equation is telling us to do. Okay. Now, this involves a lot of finding common denominators. And that doesn't make it easy, but we still have to do it. So let's take our time and do it. Now, you can expand this if you want to, if that makes it easier for you. So let's do that. I mean, I don't think it's really necessary, but I can go ahead and do that. So 4 times 3, of course, is 12. So let's put that as being 12 plus h, right? And that's plus 3 over 3 plus h, and then minus 13 all over h. Now, I just mentioned common denominator. I think it's a good idea for us to do that now. Wouldn't it be 4th in the first bracket? 12 plus 4h. Yeah, you're quite right. I keep doing stuff like that. Yeah, you're absolutely right. Thank you very much. Who was that helped me out there? That was Adam. Thank you, Adam. Right, let me just erase all of this and fix it. So that would be 12 plus 4h. Good stuff. Okay, common denominator. What would be a good common denominator for the top? Yes, Kushi and Adam, thank you very much for rescuing me there. Yeah, and Ashfa and well, everybody was ready to help me out there. What would be a good common denominator for the top? Right? Let's put this over 1. Let's put this over 1. Anything that doesn't have a denominator, we can easily put that over 1, right? So what's a good common denominator between those 3 fractions on top? Because they're all fractions. We can make them into a fraction to help us out, but they're all fractions. What's a good, so there's one denominator of 1, another denominator of 3 plus h, and another denominator of 1. What's a good common denominator for the top of that fraction, right? I need a common denominator. Let me circle them for a second here. I need a common denominator for this, and that. What's a good common? 3 plus h. Thank you, Anika. So we're going to use that as our common denominator. So here is my common denominator of 3 plus h. By the way, it's still on the end here. The limit as h approaches 0. That's still there. And all of this, by the way, is still over h. So we're doing just getting a common denominator for the top. So the key to this is remembering how common denominators work. What do I multiply this denominator here I'm pointing to get? This denominator is actually 3 plus h. So it's 3 plus h times the top. So it's going to be 3 plus h times 12 plus 4h plus, this already had a denominator of 3 plus h. So it's just going to be plus 3 minus 13 times the 3 plus h. Now, I'm hoping that that made sense, that we know from grade 11 how to do rational expressions, right? And get, common denominators and go through that whole thing. I'm hoping that that made sense. So let me keep going here. Let's expand the top of this. Yeah, I know it's a lot. I know that it's a lot, folks. Again, the limit as h approaches 0. The top of this is going to become, let's see now, 36 plus 12h plus, did I do that right? Yeah, plus 12h again, plus 4h squared, and then plus 3 minus 39 minus 13h. Okay, Anika says that made sense. That's good. All of that is over 3 plus h, and all of that is over h. So a lot of algebra, folks, a lot of algebra. Okay, the limit as h approaches 0. Now let's tidy up the top. That's 36, right? Let's just look at all of the whole numbers here. There's a 36 here, there's a 3, there's a minus 39. It looks to me as if the numbers are going to cancel each other out, because 3 minus 39 is minus 36, plus the 36, these guys will knock each other out. Hopefully we can all agree on that. What's left over is the 4h squared, right? So that's this guy right here. And then we have, what is that? 12h and 12h and minus 13h. So that's 24 minus 13. I'm going to say that's plus 11h. Oh, sorry. Let's put that back in black. Plus 11h. And all of that, so that takes out this, and this. And I still have this all over 3 plus h. And I'm going to actually, let's see if everybody understands. I'm going to multiply this by 1 over h. So instead of dividing everything by h, remember I was dividing the whole thing by h? How if I multiply by the reciprocal, which is 1 over h? All right? Let that sink in for a minute. Does that make sense to everybody in the room? By multiplying by 1 over h? Because that's essentially the same thing. Okay, Ariana says yes. Jordan, right? Everybody else? Oh, yeah. All right, okay, good, good, good. So let's keep going. So what I'm going to do now is I'm going to factor out the h out of the top of this. So the limit as x approaches 0, I'm going to factor out the h out of the top. So that's h. And I'm left with 4h plus 11 over 3 plus h times 1 over h. Who thinks they can 11 plus 4h over 3? Okay, good, good, Alexander. And you're right. We're going to cancel out those h's at this point because we factored it out. And this h and this h, those will cancel out. So what Alexander is saying to us is that what we're left with is this. The limit as x approaches 0 for 4h plus 11 over 3 plus h. Okay, so let me sort of pause there for a second to let that kind of sink in. Brendan, how about you? Are we good so far? Have I lost you or anybody else along the way? Brendan, what about you? Are you there with us, Brendan? Okay, you're following. Perfect. So here's the easy part now. It's not as x approaches 0, by the way. That's wrong. It says h approaches 0. Did I put x earlier on? Okay. So it says h approaches 0. So in this case, the answer to this is the limit as it approaches 0 is that this is gone, and this is gone. I left it 11 over 3. Okay? That's all that's left. So is it x greater than 0? Okay, good timing. All right. Okay. All right. So what it is as x approaches 0. Yes, yes, I don't know what I was saying before. It says h. I keep saying x. It's actually h. It says x approaches 0. So as you get closer and closer to 0, as the number gets so small that it's almost non-existent, what is the slope of the function actually working out to be? It works out to be 11 over 3. So here's what we now know. Back to our diagram. This line, which is a tangent line, that's just grazing the edge of the function at 313, has a slope of 11 over what again? Sorry. 11 over 3. 11 over 3. Right? Remember, all of what we've been doing is trying to find the slope. That's what this was all about. And the slope of this tangent line is 11 over 3. Now, the last part of this question is find the equation of the tangent. So this line, this blue line, has an equation. It's a straight line. So it's a good old y equals mx plus b kind of line. Can you help me to find the equation of this line, please? Can you point me in the direction of how to find, what do we know about this line that we're trying to figure out? And how can we use that to find the equation of this tangent line? It has an equation. I know you can probably look at what the picture is telling you and maybe guess what it is, but can we actually do if we didn't have the picture, could we figure out the equation of this line? You know the slope? Yeah, we know the slope. And we know a point on the line. Exactly. So what is the slope of this line again that we're trying to find? What's the slope of this line that we're trying to find again? Taj and everybody else? What's the slope of this line, this tangent line? What's its slope? It's 11 over 3. What point do we know on the line? Thank you, Ashfan, and thank you, Stephen. What point do we know that's on this line? Give me the coordinates of a point that's on this line. The 313, there you go. There you go. So let's go ahead and use that to find the equation of this tangent line. How do we set that up again? So we know generally that y equals mx plus b. Right? All lines back from grade 9 have that general slope. Thank you, Jordan, by the way. And Anika and Shashti, everybody was on the ball with that. Can you tell me what I can put in now to figure out what the actual equation is? I have a point on the line. I know the slope of the line. How do we figure out the whole equation? Can you give me some suggestions as to how I can do that? Excuse me. So we put the values that we know and solve for b. Okay, let's do that. So now the y value is the 13, because that's your y value. M is the slope, which is 11 over 3. We got that. X is the x value at that point, which is 3 plus b. There you go. And Stephen had that absolutely right. So 13, 11 over 3 times 3 over 1 is just simply equal to 11 plus b. So b is 2. Thank you, Adam. So here's my equation of my tangent line. Y is equal to 11 over 3x plus 2. And you can see from my graph that it does appear to be crossing the y-axis. The y-intercept does appear to be 2. So there you go. There you go. We have the equation of the line. We know the slope from doing the calculation of the IROC, but not using a little deviation like a 0.01. We're just going to call it h for now. Then at the end of it, we ask, what happens as h gets smaller and smaller and smaller? What happens as h approaches 0? And then we have our answer that the slope is 11 over 3. Okay. Let's try this one. Let's get the slope again of the tangent at x equals 5 for this function. X equals 5. All right. Well, the first thing we need to do is what again? Right? We know that it's at the point where x is 5. But what's the next thing that we need to do if we're going to figure out what this slope is? We need to do what first? Help me out, folks. Right? What's an important piece of information that we need right now? We need to find f of 5. Thank you, Tash. So let's do that. F of 5 is equal to the square root of 4 times 5 minus 11. Okay, so let's keep going. So that's equal to the square root of 20 minus 11, which is equal to the square root of 9, which of course is 3. Thank you, Alexander. Always a step ahead. So here's a point that we're losing here. So we're using the point 5, 3. That's the point we're going to use, the point 5, 3. When x is 5, y is 3. And we're going to go ahead and put this all together into our formula. The limit as, I keep putting x here, I don't know why, as h approaches 0 for the f of a plus h would be 3 plus h. So it's the square root of 4 times 3 plus h minus 11, right? Anywhere I see the x, I'm going to put the value that we're trying to find plus h. So that's the 3 plus h. Then minus 11. Minus the value at that point, which is 3. The y value, which is 3, the f of a. That's my f of a right there. Somebody seems to have a question. Yes, Adam. Sorry, say that again. Oh, where did I get 3 from? It was always 5. You're absolutely right. Let me fix that. Thank you. Thank you. Who was that? That was Adam? Thank you, Adam. Okay, so it's actually 5 plus h. It's a good thing that people are paying close attention here. I was using the y value rather than the x value, so you're absolutely correct. All of that over the h. Okay? All right. So remember, this is let me just circle it here. This part in red right here is the same thing as this part right here, f of a plus h. Just putting in the a, which in this case is 5, thank you, Adam, plus h, and multiplying that by 4. Where I saw the x, I put the a plus h, minus 11, the square root of that, minus 3, 3 being the y value, all over h. All right, so let's keep going. Let's keep going. This one is going to be yours later on. So let me bring that further. Oh, sorry. Let me bring that further down. And let's come back up here. So why don't we sort of do a little bit of algebra on this part right here. Limit as h approaches 0 of the square root of 20 minus plus 4h minus 11 minus 3 over h. So 20, 4 times 5, 20, 4 times h, 4h minus 11 over 3. Okay, so let's see if we can tidy this up some more. The limit as h approaches 0 of the square root of 20 minus 11 is 9 plus 4h minus 3. Now remember that the 3, this minus 3 is not being square rooted. The only thing that has to be squared is the 9 plus 4h, and that's over h. All right, now there's nothing we can factor out this time, so we can cancel out that h. But we have a problem. The problem is that we can't just, so the question is, what is it as h approaches 0? Now, all we've done in the past is we just threw the 0 in there and then we had an answer. We can't do that this time because we have a denominator of h, and if we were to substitute in h as 0, this is undefined. Okay, so let's see what Kushi is saying now. So 3 plus 2 h could be done to factor. Let me see if I can understand what you're saying now. You're trying to factor 3 plus 2. Oh, I see what you're trying to do. No, okay, I understand. I understand what you're thinking. Can I just take a quick aside here? I understand what you're thinking. The square root of 9 plus 4 is not equal to the square root of 3 plus the square root of 2. It's not. Let me just tell you that it's not. I know it's a temptation to think that it is, but it's not. If this was the square root of 9 times 4, then yes, that is equal to the square root of 9 times the square root of 4. That is absolutely correct, but not for a sum and not for a difference. I understand what Cauchy is suggesting right now. So it works for a product and works for a quotient. It does not work for a sum or for a difference. So the sum of two perfect squares, you can't split it up and say it's a square root of, actually, I should have said, I messed this up a bit. It's not equal to this. It's not taking the square root of 9 and then the square root of 4. So it's not equal to this, is what I'm saying, Cauchy. You see what I'm saying? So we can't do that. No, we cannot do that. If it was a product, fine. If it was a sum, no. So we can't do that. So let me erase all of this here. But there is something we can do, though. Right? There is something we can do. So look at what we have there. We have a denominator, which is an h, right? So we can't just go ahead and throw in the 0 because it's going to become undefined. So what are we going to do? What are we going to do? What is the value of this function as h approaches 0? Not when h is 0, because when h is 0, we're in trouble. When h is 0, it's undefined. Is there a strategy that we learned maybe yesterday that might help us out here that you think could be applied in this case? What do you think, folks? Any ideas from yesterday's class that might apply in this rationalizing the numerator? Thank you, Adam. So we're going to do exactly that. I'm going to leave out the limit as h approaches 0 for a bit because it takes up quite a bit of room. And what we're going to do is we're going to try to rationalize the not the denominator, but the numerator. So I'm going to take the square root of 9 plus 4h minus 3 over h. I'm going to multiply that by the conjugate of the numerator, which is the square root of 9 plus 4h plus 3. But of course, I have to do that at the top and at the bottom. So the square root of 9 plus 4h plus 3 on the bottom as well. That's the conjugate. Thank you, Cauchy. You're absolutely right. Okay. Let's see where this is going. Oh, jeez. Let's see where this is going to take us. This is going to be your question later on. Let's see where this is going to take us. Now remember, if it's a conjugate, when you multiply these two things together, you're going to end up with a difference of squares. It's going to be this thing squared. All right, let me use a different color for that. It's going to be this thing squared minus this thing squared. That's what we're going to end up with. So let's do that. When you square the square root, as you know, you're going to end up with the thing without the square root. It's going to be just simply 9 plus 4h, Mr. Kamak, 9 plus 4h minus the square of the 3, which is 9. That's all over h. This times the square root of 9 plus 4h plus 3. So that's multiplying the h by this denominator here is what I've just done. So this h here is being multiplied by that. Now, luckily for us, the top, excuse me, is just going to be left with 4h. The bottom is going to be left with h times the square root of 9 plus 4h plus 3. Now, why is that good? Why does that help us out? Because remember, our issue was that the h at the denominator was going to cause a problem. Is it still a problem? What do you think? When we write it the way I have written it right now, is it still a problem? No. We can cancel it out. Absolutely. So we'll do that. So really what we're left with at the end of all of this is this. 4 over, the h is gone, so it's the square root of 9 plus 4h, sorry, plus 3 is what we're really left with. That's all that's left. And now we can ask the question of the limit as h approaches 0. We can now ask that question because I keep doing that. Because that question is easier to answer by just plugging 0 into this. It's okay for us to plug 0 into this. So what we're going to be left with is this. 4 over the square root of 9 plus 3. Which, as Alexander, who is always like a minute ahead of us, which is equal to 4 over 6, 3 plus 3 that is, which is 2/3. So Cauchy and Alexander were both 100% correct. Okay, I know that is a lot to throw at you in a short time, right? So what we're saying is that at the point, if I were to measure the slope of this line, if I were to draw this, if I were to graph the function of 4x minus, the square root of 4x minus 11, at the point where x was equal to 5, if I put a tangent line there, my IROC, right, the instantaneous rate of change works out to be this fraction down here, 2/3. That would be the slope of the line at that point. A positive 2/3 would be the slope of that line. Does that hopefully make sense to everybody?